Given the energy level diagrams for X, Y, and Z, we can rank them in ionization energy from least to greatest. Note that there are 6 possibilities. When you see an energy level diagram like this, note that there may be other filled orbitals at lower energy, and there are other empty orbitals at higher energy. The diagram does show the lowest unoccupied orbital for X and Y, and there would be more higher up. And there would be some for Z as well, but they're not shown. Also, you might think we're only showing S orbitals in the diagram since there's only one line at each energy level. If these were p-block elements, we would show 3 orbitals in the highest occupied sublevels. But we're trying to save space, so we only show 1. To rank these in ionization energy, we need to identify the electron that will be removed in each atom. The electron to be removed is always the highest energy electron, and we show that with the blue circles. Ionization energy is the amount of energy it takes to get to the top of the diagram. So the smallest ionization energy would belong to Z, whereas the largest ionization energy would belong to Y. The correct ranking from least to greatest would be ranking number 5. For electron affinity, we need to identify the open spot that an additional electron would go into in each atom. We do that with the yellow circles. Notice that in Y and Z, the highest occupied orbital is half filled, so there is space for one more electron. In X, the highest occupied orbital is filled, so the first empty space is in the next sublevel up. The electron affinity can be determined by the energy change an extra electron would experience when adding to each atom. Here, X would have the smallest electron affinity, whereas Y would have the largest. In ranking them from least to greatest, ranking number 2 would be correct. One final point to make. In looking at trends on the periodic table, we said that ionization energy and electron affinity had the same trends. But here, they are not identical. Why is that? Ionization energy probes the energy of the highest energy electron, whereas electron affinity probes the energy of the lowest energy hole. In Y and Z, these probe the same level. We shouldn't expect ionization energy and electron affinity to give the same numbers, since they're measured in different ways, but the trends should be consistent. So Z will be smaller in each measure, while Y will be larger. But in X, ionization energy probes the lower energy level, whereas electron affinity probes the higher energy level. So X may appear out of line in one of the measurements. In real atoms, this happens when a level is full. For example, in the noble gases. Ionization energy probes the valence orbitals, but electron affinity probes a higher energy level.